Melting of aluminum alloys. Aluminum alloys can be melted in direct or indirect fuel fired furnace or in electrically heated furnace like crucible furnace, induction furnace, etc. The present section describes the details of lift out type crucible furnace. Lift out type crucible furnace. The lift out type of crucible furnace is one of the oldest and simplest type of furnace used for melting aluminum alloys, also other non-ferrous alloys in small volumes. The furnace as illustrated in its simplest form in figure consists of a crucible made from a refractory material, usually a clay graphite mixture or of a high temperature steel alloy. The crucible itself acts as a ladle. The charge placed inside the crucible is heated through the walls of the crucible by means of heat sources like oil, gas, or electricity. After the melt has reached the desired state, the crucible is lifted out of the furnace with tongs and the molten metal is directly poured into the mold. Hardness used in aluminum castings. The mechanical and physical properties of aluminum castings are enhanced with the use of alloying elements. However, aluminum is a low melting point 660 degrees Celsius metal, and most of the alloying elements having favorable properties have comparatively greater melting points. In such a case, the alloying elements do not mix readily with the low melting point aluminum metal, and hence master alloys or hardeners are often used. Hardeners are available in a number of alloys including calcium, carbon, copper, chromium, manganese, magnesium, nickel, silicon, titanium, vanadium, and more. For more, chromium has a melting point of about 1875 degrees Celsius, is used as a hardener with the aluminum melt in order to impart strength, hardness, and oxidation resistance. The aluminum chromium alloy combination is called as master alloy and chromium as hardener. Initially, chromium is allowed to reach the molten state and in this condition solid aluminum is added and is quickly dissolved in the liquid chromium. Aluminum based master alloys which contain the hardener elements in high concentrations now provide a convenient and economical way to add them to molten aluminum to achieve the desired final properties. These master alloys readily go into solution at lower liquid aluminum temperatures, thus minimizing dross formation and solubility of hydrogen. The amount of aluminum and hardness used is calculated during the course of melting so as to bring the final aluminum casting to the desired specification. Drossing. Dross is a mass of solid impurities floating on the surface of low melting point metals such as aluminum, tin, lead, zinc, etc. as a result of oxidation of the molten metal. With reference to aluminum castings, the term drossing is specially used to denote the formation of aluminum oxide and other oxides that collect on the surface of the molten aluminum metal when coming in contact with air. Dross can be minimized when melting is made faster or protecting the molten metal coming in contact with the products of combustion or atmospheric air. However, even with its formation, the dross product need not be considered a waste material, instead can be recycled either mechanically or chemically and reused. Oxidation, separation and removal. Drossing fluxes are designed for chemical means fluxing to promote separation of the aluminum oxide Al2O3 dross layer that forms on the surface of the melt from the molten metal, either solid or chemically active gaseous fluxes containing chlorine, fluorine, chlorides, and or fluorides are used for the purpose. The drossing flux reacts with aluminum oxide Al2O3 in the dross layer by de-wetting of the oxide melt interface to provide effective separation of oxides and other included matter, thereby helping in recovering of aluminum metal. In the mechanical process, the hot dross is placed into a press that squeezes and separates into aluminum metal rich particles and aluminum oxide rich particles based on density. The metal rich particles are then melted into a furnace to remove the remaining oxide particles.